Welcome to lesson 28 part 2, where we look at strategies in dealing with integer over and underflows. As you can see here, I've allocated or assigned the variable int or I of type int to its max value, and then I've added 5 to it. And this is a positive number, and you see it's overflowed, in other words wrapped around to a negative number, so overflows occurred. This makes it difficult to find bugs in your application, because it may be, if you're using an int and it goes over, you're not aware that it's overflowed. So it may be that you don't want an overflow to occur, or that you want to know, or you want to be made aware that an overflow has occurred. How do you go about this? Now in this case, I'm taking the same arithmetic expression over there. I'm taking its max value, adding 5, but I'm assigning it to a long, a variable of type long, and we know that a long is larger than an int, because this results in an int, and the int is 32 bits and a long is 64 bits, and in this case, as you can see, it didn't go into a negative number yet. In other words, its max value plus 5 gives you this value over here. So from this we can see that if we know, it's important to know what types we're going to use before we assign the type, so that in a program doesn't overflow. Just want to show you another thing which I've mentioned before. Now, as you can see in this example, although I'm allocating the result of the arithmetic expression to a long because I'm casting it here, it's giving me an overflow. So one should be aware of this, because what's happening here, this arithmetic expression evaluates to an int by default, and it overflows, and then it's cast to a long. So this won't work. So you need to convert this, one of these, into a long, so that, like I did here, I made it, I used the long's literal value, the L, the suffix. Otherwise you may think that you've actually converted it to a long and want overflow, and it still overflows. Some error, I've got 2 L's here. Fix that error. Now here I'm allocating long's min value, and I'm decreasing it by another 20. So I'm going smaller than allowable long value, and you can see it's gone from a negative, the min value, to a positive, so it's underflowed. And as you can see that the long value has also got a maximum minimum, although highly improbable that you will need more than a long. But what happens if you overflow on a long value and you used it? Okay, what I'm doing here, I'm actually taking long's min value and then decreasing it by 20 of type float. So this operation here will be converted to a float, and then assigning it to a float, and you can see it didn't wrap didn't wrap around, it continued as a min value, so there no wraparound is occurring. So as you can see, we could use a floating point number as we can see there's no overflow, and that's because a float, it uses scientific notation, so it can store larger numbers than your long in that sense. Okay, but now what if we don't want to use floating point numbers? We want to stay with integers, in other words no decimal spaces. Well, Java's got you covered in that as well, and we'll do it in the next example. Just going to display the long value here, so you can see it did underflow there because that's a positive. Its min value is a negative number, and you can see here when I reduced it, it went positive. And while we got that, okay, here I'm using big integer from the java.math class, package I mean, and what I'm doing here, the big integer takes a string as a parameter, so I'm converting that to a string. So I'm allocating big integer the variable bi1 with long's min value. As you can see, there it is, which is the same here for easy reference. This one is the same as this one. Then I'm allocating another big integer variable with a value of 20 of type long. So I've got a big integer value of 20, and when I subtract the two, it's not overflowing, as you can see, it's not overflowing or underflowing. It's not wrapping around, in other words, and it's still a negative number. So I've added 20 to that one, 808, 828. So you may ask me, what happens if I want to store a value that's larger than a big integer, or if I want to store a value larger than big integer? Well, that depends. How large can you store? All depends on, because big integer is not restricted. It's as large as your system's memory. So yes, so you may as I say, why not just start from the beginning, assigning all your variables with big integer? Well, for now I'll just say that there's a trade-off in doing that, and I'll be looking at that on later videos, so look out for those. One last thing that you may have noticed, that I mentioned that the big integer class is in the java.math package. Now one knows that the standard Java class one creates, only the java.lang package is loaded by default. So how did I use the big integer class without importing it? Well, as you know, I'm using JShell here to test our snippets of code. Now I use it as it's a great tool made just for this purpose, where you want to learn Java and not necessarily to write all funny classes, just to test certain concepts. You can use JShell. Apart from the java.lang package, JShell imports a number of packages by default just for the purpose, and the java.math is one of such packages. Now I can show you here. I'm just going to list the imports, and as you can see, here's the maths class that it by default. Obviously you can import others, but it comes standard with all of these apart from the java.lang package. Now you're welcome to visit my playlist on video tutorials on JShell for further information on JShell. In the following section where I typed the code, and yeah, I'm showing it with a little sketch, I used the new big integer, and I created a big integer with a long.min value, and then I went and subtracted using a big integer's one constant, and as you can see, the big integer did not under or overflow. It went from a long that ends at 808 to 809, and I did the same using a big integer constant 1, and this time I did an addition to it, which you can see on the graphics here. Now, what if I want to use a primitive type such as an int, and I want some way of knowing when an overflow occurs? Well, I'll be discussing that in the next video. We have reached the end of this lesson. We saw that we need to do some upfront analysis when deciding what primitive integer type we are going to use, and select the appropriate one so that we don't get hard to find wraparound bugs in our application. We were also introduced to the big integer class found in the java.math package. I hope you've enjoyed this lesson, learned something from it, and please don't forget to press the subscribe and notify button. I've also got a Facebook page related to this channel. You are welcome to join my adventure channel where I share photos and videos of various activities. Until we meet again in our next lesson, I wish you well and happy coding.